just confirm that you can see my presentation. Is it
Yes,
working?
it is working. And before, Rod, sorry for interrupting, an important message to the participants. At the end of the presentation, at the end of the session, approximately on the last 10 minutes, there will be an opportunity to raise questions. I'm asking everybody to put your questions and paste your questions into the chat, and I'm going to read them, and Rod is going to answer those questions. So feel free to use the chat. It's not only for the last 10 minutes, but also you can start using it right now. And at the end, we will answer that. Thank you.
Thank you. So, like Bilal said, my name is Rod Adam. I'm located in Brazil. I am one of the client transformation site reliability engineers at Kendra. I'm part of Kendra's Center of Excellence for Site Reliability Engineering. And before we go through this material, I want to put a disclaimer here. It's very important that you understand all opinions expressed during this event are my own, and they are not necessarily the opinions of Kendra. With that said, let me go to the agenda for today. So I think this is an agenda, but also the key takeaways for this event. I want to answer those questions, and the first one is why site reliability engineering, and why now? Why this is important for you and for companies that are trying to modernize their way of working. Okay. The second question is really what is site reliability engineering? Hopefully I can give you a good sense and a good explanation about them. Then I want to make sure you understand why this is getting traction, because it makes systems more reliable, and that means more profitable. And in the end, I want to explain what it takes to become a site reliability engineer, an SRE. Maybe I can convince some of you to become one. And in the end, I'm going to put some further information where you can read more about this. And that's it. That's the agenda for today. So without further ado, let's talk about why site reliability engineering. Why bother with that, right? And I like to answer why by looking from the people perspective, right? So hopefully you can see the numbers here. I just checked this yesterday. So if you go to LinkedIn and search for site reliability engineer in European Union region, you're going to find more than 46,000 results. So supposedly there are more than 46,000 job opportunities or job openings for SRE. If I try not to restrict my search to this term, so I put site reliability engineer in quotation, it goes to 1,200 open positions. So yes, it's a hot profession right now. And I try not to do some research about the salary. Unfortunately, I don't know if 68,000 euros per year is good salary. I think so. Well, it's a lot for me anyways. So this is the average salary for a site reliability engineer in Germany. Unfortunately, I was not able to do the same research for Hungary, but just to give you an idea about how much an SRE earns in Europe. And so yes, it's a good salary, right? Then why this is important for companies, right? And the short answer is an unreliable system is an unprofitable one, right? If you have an unreliable website or sales platform or B2B system, if it is not working pretty well, doesn't have performance, is not resilient, it's not available all the time, then yes, you're not going to have profit with that system. And the reason for that is because we don't care much about outages anymore because the systems are very, very resilient. Now we really want to see if we can make those systems work properly and with performance, so the users of those systems can really utilize the application inside it. So slow is the new down. You don't want to have a slow system. You really want to have a very performatic system so you can improve your sales. And there is a question here, right? So if you don't have performance, if your system is not performatic, how this impacts your business? According to this research from Aberdeen Group, it means if you're taking 1 second delay to respond to your user, to the system user, after this person clicks a button or tries to fill out a field there is a 7% reduction in online customer conversion. So this person will go to another competitor. Also, there are 11% fewer pagers views. You're losing customers, and 16% decrease in customer satisfaction. So net promoter score. So yes, reliability is very important. Okay. Okay, so now hopefully I got your attention for site reliability engineering. Hopefully you are now more interested on this topic. So let's try to explain what is site reliability engineering. And I should start by saying it's more than a model, okay? So if you think about site reliability engineering, you need to think about 3 different things. First, there is a profession. Secondly, you have a mindset, a proper mindset to work as a site reliability engineer. And you have a set of core practices. So those 3 things are the pillars for site reliability engineering. And like you can see on this slide, you have the profession. Profession is very simple. It's called site reliability engineer. We didn't invent this term. Actually, Google did in the beginning of the 2000 decade. And this profession is defined by a set of core skills and, of course, skills on the hybrid cloud technologies and products. Okay, so we live on a world where you have cloud technology and also on-premises technologies. And an SRE must understand both words and work on trying to integrate those 2 different words. Also the mindset. So you have core values, principles. We also share values with DevOps. So we are like a brother or sister to DevOps. And yes, we work on a disciplined agile methodology. We try to incorporate most of the agile way of working. And the last thing, yes, we have a set of core practices. So if you want to compare that to PMI, since we have many project managers here, you can think, yes, what is the profession? Well, you have project manager, you have a Scrum Master, also have the PMI values and principles. You have the Agile Manifesto on the middle column. And for the practice, you have the PMBOK, you have the Agile Practice Guide, you have the Scrum Guide, you have XP and Kanban. So that forms the Agile Product Management. It's a parallel to site reliability engineer. So probably this will resonate with your knowledge right now. Okay. What else? If you look at the professional profile, the site reliability engineer, this person has a very interesting mix of knowledge and skills that spans out through different domains. So I'm going to explain a little bit about the core skills, but yes, you need to understand about software engineering, programming, data structures, data analysis, data science, algorithm, and of course, systems management. So this is a technical profession that spans through multiple knowledge domains. And of course, the focus of any SRE is the reliability. You can think reliability as a composite dimension on top of availability. So systems needs to be available. Yes. Systems needs to be resilient. Yes. It needs to be secure and scalable. So you can think reliability as going beyond availability, resilience, security, and scalability. Okay. And of course, these we are talking about IT systems that have services, and they of course have end users, right? We are really now looking at the end user of those IT systems, and their mission is very simple. They want to progress, protect, and provide a very good user experience. Because if you make the end user happy, then the customer is happy, right? If the end user is consuming more, is paying more, is have more fidelity to your platform, then yes, you're making more money. Okay. And on the right side here, we have the environment. What is the environment that the SREs are located nowadays? And you can see, first of all, change, right? If you have worked with IT systems before, change is rapid and constant, right? The only certainty about IT is that it's going to change, right? So they need to be very adaptable to rapid and constant change. Also, like I said, the skills is um, a variety of different domains, so they need to understand many types of different technologies and products, right? And they live in an environment that is trying to go to no ops. If you don't know what is no ops, it means you don't need operations anymore. The systems are smart enough to be self-healing, self-scalable, self-providing. So you don't need a system administrator in this no ops environment, because you have AI, you have smart system, intelligent systems that are capable of take care of themselves. Okay, so we need to go to that direction. So SREs are very good on automating, on create automation. So this is another part of this environment. And like I said, no, because the big data, because the number of data we need to analyze, we need to have a specialized tool that is capable of, uh, artificial intelligence. So this is called AI ops. So you can manage your operations, IT operations, through the adoption of AI. It's not like chat GPT, okay, before someone asks me. But yes, it's a type of AI that analyze data, big data, and gives us a predictive, preventive analysis. It tries to detect anomaly. Okay, so this is the environment and the professional itself. So why SRE was created? So that's a very good question. And on this slide, I can also answer why DevOps was created. So basically, we always had two different teams and departments or organization, the development team and the operations team. So who develops a solution or a system, and who takes care of that system or solution afterwards. And you can see, if you live on any technology company, this is a huge conflict, and there is a lot of distrust between those two teams, right? So we have developers, we have sysadmins. If you are not on my team, you are against me. I don't like you. I don't want to work with you. And the main reason for this conflicting environment, this friction between those two teams, is because they had different goals. If you think about developers, they really want to create new features. They don't care too much about stability, right? They want to create new features, new functions, and they are measured against how many features they develop, right? On the other hand, we have the system admins or system administrator. They focus on the stability because their objective is, of course, to have a system with performance, reliability, and correctness, right? And you see, they have different establishment and functions and objectives. So from the developer side, they say, well, we don't want this conflict anymore. So let's go to the middle, right? We don't want to keep fighting the system administrator. So they create DevOps. DevOps is a shift right. So they try not to create a common set of skills, incentives, and goals. In the SRE is the system administrator trying to incorporate more of the development. So shift left. And guess what? They meet in the middle, right? So DevOps and SRE, they are sisters or brothers, or they complement each other, but they have the same orange or the same motivation to exist. We want to ease or to eliminate this conflict between development and system administration. So DevOps is a movement from developers to operations, and SRE is a movement from system administrators to development. Okay, so that's something that explains the origin for both. And if you want to summarize SRE somehow, it's not possible to summarize pretty well, but if I want to try to explain what we have inside SRE, I cannot even say SRE site reliability engineer in a nutshell because it's a very, very big shell here. But in the middle of this picture, you can see the Google books. So Google did something very awesome and amazing. They open their knowledge on site reliability engineering to the public. Okay, anyone can read those books for free, and you can modify, you can adapt, you can adopt, you can implement. So they were very, very keen to change the whole world about site reliability engineering. And they create those books, they wrote those books, and they open source those books. So they are available for free. Anyone can get those books. Anyone can modify, like I said, can use, can adopt the way you want. Also, besides the books from Google, you have the SRECon. This is the largest conference, international conference on site reliability engineering. And of course, like any conference, you have papers, you have proposals, you have new techniques, new practices. And of course, if you are in this world or you are an SRE, you need to keep an eye on those SRECon events, okay? And from those books and the papers inside these SRECon conferences, we can extract the principles, the values, and the practices. That's it. So we are not reinvent the wheel here. We are not saying, well, this is Microsoft site reliability engineering model. Oh, this is not Kyndryl site reliability engineering model. This is not Amazon site reliability engineering model. It's not even Google site reliability engineering model because they opened that to the public, so anyone can modify. So we are using the same source. You can say the same source code if you want, but we are using the same source. So an SRE, a site reliability engineer at Kyndryl, can work as an SRE at AWS or Azure or Google or any other company that's adopting the same principles, values, and practices. So in that sense, site reliability engineering is very similar to what the PMI is doing. Okay. So Just to explain a little bit about the principles we have here, and they are very interesting because they promote a new way of doing systems administration. So the first principle here on the purple box is ops to scale with load. And that means if you have an operations and the load or the workload start to increase or raise, you don't want to put more people, right? In the past, the first solution was if I have more application, if I have more systems, if I have more machines, VMs or servers, what you're going to do is put more people. We learned that that doesn't work, right? Because more people means more coordination. And if you remember, the communications area inside PMBOK, it gets very, very complex where when you have more people, right? It's much more complex to coordinate and to make sure that they have the same knowledge and the same information. So instead of putting more people, you want to start automate your tasks, your administrative tasks, your systems integrations, um, your procedures, your standard operating procedures, your run books. So there are various ways to say that, but in the sense, you want to create code. You want to create a script that will make your operation scalable. So you don't need to put more people, but you rely on the automation to do the work, most of the work. Of course, not all the work can be done by scripts, by code, or by AI. That's good, right? Because otherwise we are going to lose our jobs soon. But yes, it's automation. And we don't stop in automation. It's much more about optimization of the IT systems, administrative processes. And we are eager to eliminate toil. Toil is any repetitive manual task, like, if you every day you need to check, process inside a VM, this is toil. Why you need to check that? You can put a script doing that for you and just report the health check back to a group of people. So in this case here, we want to eliminate toil. The second bullet on the purple box is very important because if you only work on reactive work, like, incidents, chains, problems, um, doing troubleshooting, doing fire drills, you don't have time to spend on engineering. And by doing engineering work, proactive work, that's how you improve your system's reliability. So this principle says, yes, you need to have time to do engineering work, to improve the systems, to create automation, to um, uh, improve the monitoring layer, for instance. Okay. So another principle that we follow to the heart is you need to have time to do improvements, not just operational work, day-to-day work. The third bullet um, is a way to break the silo between developers and system administrators. So every time we have more work that we can absorb, let's say because an assistant is stable, there is a lot of incident, there are a lot of problems, and we don't have enough SREs or system administrators to take care of those problems, then this excess operational work goes to the development team. This is very, very interesting because they know if they don't do a good job, they will get the operational work as well. No, it's not just a way to punish them. Of course, we don't want to punish them, but we want to share the pain of an unstable system. Okay, and by sharing this pain, they will improve, the way they release new versions, right? They will start taking care of certain aspects of the release services. And usually we share That's of course a principle to be followed. 5% of the operation work with the development team. So in the end, what we want is that a developer can become an SRE, and an SRE can become a developer. So you see, you gain flexibility, and you gain several other possibilities to have a more robust organization just by doing that. Of course, it's not easy to implement, but should be a principle, right? Something you put in your heart, say, yes, I want to get there. Also, another principle here, the fourth bullet on the purple box, confusing colors. You need to measure up your service, right? Are we improving something? Are we doing something good for the system's reliability or for the end users? And for that, you need to well-defined, you need to have well-defined service level indicators, objectives. You measure that against an agreement, right? I'm pretty sure you know SLAs, SLOs. What's different here is SLI. So we have a technical definition of what should indicate the service level. This is very important for our series because if we don't do, if we don't follow this principle, then how can we say we are doing a good job? Why you need SREs after all, right? On the right side of this purple box, you have other principles, error budgets. So this is the remaining of the objective. So it's 100% minus the objective. So if the objective of SLO defined as 99%, the remainder of this SLO is 1%, right? So 100% minus 99% is 1%. So the error budget is 1%. These budgets you can use to experiment, to test, to do new improvements on production, okay? Because you know, even though you lose 1% by having problems, you're going to meet the SLO because SLO is 99%, and you can use this time, this remaining time, to help improving the system's reliability. So error budget is not something, another principle that's very different from the traditional way of manage IT systems. The next one, observability, is we need to make sure we understand what is happening inside the systems, the inner states of any system, by monitoring the outputs. So observability is a principle to have a full stack monitoring of the IT systems. And also one of the key practices inside observability are the golden signals. So if you don't know what to monitor on an IT system, try this out: latency, error rate, traffic, and saturations, because those signals will easily translate to end user symptoms. Okay? So this is very important as well. Next one, actionable symptom-based alert. So you don't call an SRE in the middle of the night because the CPU loads or because an infrastructure component has a big load, or because a component of the infrastructure is down if you have other 5 instances of the same component. You only alert, you only make a high priority incident if it is affecting your end user. Okay, if it is making your system slow for the end user, yes, it is an alert. If you are making the system unavailable for the end user, yes, this is an alert. But if you have problems on infrastructure that the smart system can take care alone, why you want to call everybody in the middle of the night for that? Doesn't make sense. You're only spending energy of your team, right? So only actionable symptom-based alert, and those symptoms are from the end user perspective. And the next one, very interesting, blameless postpartum. This is where we do RCAs, root cause analysis, but we are moving from a single root cause because our hybrid cloud systems are very, very complex. And most of the time, you don't have a single root cause. You have a combination of multiple causes and multiple factors to affect your system. So it's not just a simple RCA where you can apply the 5 whys. But yes, you need to do some kind of cause analysis there. Usually we do Ishikawa, that that is part of the uh, PMI practices. And it should be blameless because we don't want to blame a person. Okay, we don't want to blame a component or infrastructure component, because if you do that, we are saying no. If we don't have that person, we don't have that component, then the system is 100%. That's not true, right? They were contributing factors, and if a person made a mistake, you need to understand why. It's lack of training. It's because the button colors are too similar. Unless this person is a saboteur, this person wants to do sabotage, then yes, you can't blame a person. Okay. And another principle from Google, we're not doing this one at Kendra, for instance, but you want to know a common staffing pool for SREs and software engineers, right? That way you can have the same hiring process. And if an SRE wants to work as a software engineer, that person can. Or if a software engineer needs to work as a SRE, yes, it's possible. So those roles are interchangeable, and that gives you flexibility. Okay. On blue side here, you have the values. Some of those values are shared with DevOps. You can see some of them here. But like I said, this is an holistic approach. So systems thinking is very important. I know some of the Scrum Masters are adopting systems thinking. So we as well. Um, we use systems thinking to identify multiple cause, multiple factor problems during troubleshooting, for example, or if we want to do more reliable design, then we apply systems thinking as well. So this is a value for SREs. Also, our decisions are data driven. So this is something we got from data science. We don't do any technical decision based on good feeling or um, any ad hoc manner. We really use data and data analysis to support our technical decisions. We are an engineering discipline. We like risk, calculated risk, right? Um, of course, it's very important to deploy as many releases as possible, because each release will have new features, and this means money. But of course, we need to calculate risk and assume those risks together. Like I said, eliminate oil. We love that. We hate manual repetitive tasks. Is if you want to know to do repetitive tasks, there's other jobs for you. We like to remove this technical debt, those technical risks that are implicit in the systems design. Simplicity, right? This is coming from Scrum, right? The art of doing only the necessary, right? Collaboration, of course. You don't work alone on those complex systems. Share responsibility. So yes, developers and SREs work together and they share the same responsibility. Trust and transparency, like any Scrum agile framework, right? Not necessarily Scrum, but any agile manifesto based methodology of working. Okay. And on the right, on this orange color, PMI orange, you have the SRE practice. We have a huge list of practices, like the PMBOK. They are organized per areas. You can see on this pyramid. We have practices on monitoring, on the incident response when you have an alert, on doing post-mortem, root cause analysis. We have practices on testing, release procedures, how you test a software application, how you release that to production systems. Um, we have practice on capacity planning, so how you can prepare for the future, stay ahead. We have practice on development cycles and on the product itself. Okay, so you see, it's very similar to the PMBOK. You have multiple practices, and they are organized into areas. Okay, so hopefully this gives you a good idea about which principles we follow, which values we treasure, and which practices, at least the areas of practice. I don't think we have time to understand each practice, core practice here, but at least give you an idea what are the three main components or features of site reliability engineering. In the next part, I'll try to make you understand how it makes our systems more reliable. And again, if the systems are more reliable, then they are more profitable. Okay. And of course, this goes beyond simply making them available. Available is not enough. Like I said in the beginning, slow is the new down, right? And this is typically SRE platform. On the first column on the left, you have a system, right? And the system has infrastructure, has application, has user interface, can be your browser, can be your mobile phone, right? You can use an app on a mobile, or you can use it through a browser, or you can have a client. You have microservices, you have containers, you have database, you have storage, you have multiple things there, multiple entities. What's important in the middle is how we make those inner states, internal states, visible to an SRE. So you see on the middle, on the blue boxes, you have all the tools, all the platforms we use, to monitor or to collect data from those components. Okay. So just to understand a little bit, the first one is synthetic user monitoring. So we create bots that mimic an user going to any system, right? So that way we can check, if the system is working by doing synthetic monitoring there. You can also monitor reusers as well. We do distributed tracing, so we know if you buy something on a website, we know which components you have used by tracing that ID, transaction ID. We monitor the application API performance. We collect all the logs, and of course, we monitor all the infrastructure components, right? And those tools, those monitoring tools or platforms, they generate data, right? The types of data is very simple. We have metrics, we have traces, we have logs, we have events, and this creates a big data. The middle in purple, melt, metrics, events, logs, and traces. And of course, if I go and look at this melt without any tool, without any data analysis, it's impossible to understand because it's a huge quantity of data. Most of the time, this data is not human readable. Half, I would say. So we need to apply visualization first. So we need to have dashboard that makes sense of this quantity of data. So we can see on a dashboard graphs, counters, gauges. So that facilitates our work, right? Instead of going to a database and try to query the logs or the metrics, the traces, we just use a dashboard. So we have a graphical interface where we can, yes, we see a strange behavior on this metric, things like that. Also, we have smart systems that are able to detect an incident and say, well, this event is not good. This impacts the user. So they can alerting, notify the SREs. So you don't need to keep an eye on the dashboard. Dashboard is great to understand this history, historical data, right? But the alerting notifications helps us to receive, what's important. And also we have the AI ops. So we have the AI model consuming, ingesting all that melt data, big data, and try to understand the patterns and what is an anomaly, what is normal behavior. So we also have that interface as well. Okay, so that's how an SRE works nowadays, through dashboards, through alerting notification systems, and through AI op insights. Just to understand how, I think this is a good question from the chat. Yes, which metrics help us understand if the SRE model adoption is going to a good direction? So this is the landscape. This is a typical platform of measurements. Okay, so in the first column here you have the system. The second column you have monitoring, which is responsible, like I said, to collect data and telemetry from the systems. You have the events, right? You can put thresholds for those events. You have the notification system. Fortunately, one of the possible notification systems is the help desk. So if you're not able to detect an anomaly or a problem, then the user, guess what, will call the help desk, say, well, you have a problem. I can't use the application. That's terrible, but yes, it's a possible notification system. You have the service levels, and then you have the KPIs. So our key performance indicators as engineering discipline are listed here. So basically, mean time to detect, how fast I can detect that problem, mean time to knowledge, how fast I can put someone to look at that problem, mean time to repair, how long it takes to repair the system, resolve the incident, of course. Mean time between failures, how often those problems happen, right? It's every month, it's every quarter, every day, out, right? Another possible measure are percentage of end user tickets. So how often your end user calls the help desk say, oh, we have a problem. You didn't detect that, right? Percent of automated toil. So among all those toil that you have in your operations, how much of them you have really automated, right? So you make your operation scalable again. And percentage of error budget utilized. It means, are you using the error budget for something good? That's a key question for us. So those are the KPIs for the site reliability engineering model adoption. And if you don't know what is mean time to something, mean time to what, right? I have definition here. So just to understand this graph, you have the incident start and the incident end in the middle. You have those phases, right? Detect the incident, isolate it, diagnose the incident or the alert, fix it, and verify. Okay, and between when it starts and when you have uh, one phase finished, you have the mean time to something. Okay, just to understand what is really important for us is the mean time between failure. So the longer is this period, the better, right? Because you don't have to have the same incident happening every month or every week, right? It's horrible if that happens. You need to really do post-mortem. And reliable time is when the system is fully available, performatic, and the user can completely use it without any problem. It's the reliable time. So this is also the mean time to failure. Okay, I don't like the MTTF because it's a pessimist. I like the optimistic. It's the reliable time. Okay, it's not MTTF. And then this is how we make our systems profitable, right? We have this table, and this is, I like to call this a consequences, cause consequence table. So if you have observability, principle observed, then you have a shorter mean time to detect, right? If you have a good monitoring, full stack monitoring, your time to detecting a problem is shorter, right? And of course, you reduce the downtime, and you have a better average revenue per end user. Yes, your website, your application is available and performing according to the design. Then your end user is happy and consuming your services, right? So the average revenue per end user is better, right? We don't have the percentages here. It's something that we are working on. And you can see for each of those principles, if you really implement them, you have an impact to the SRE metric, KPI. You have a service impact. And by having a service impact, a good positive service impact, you have a business impact. So maybe you can improve the revenue per end user, or decrease the expenses per end user, or you can have a more fidelity from your end users, all right? Or you have a better net promoter score, or cost of acquisition, or lifetime value for each end user. So yes, this is how site reliability engineering makes your system reliable and profitable, right? And if you don't know any of those business metrics, I put the definitions here in this material. And what takes to become a site reliability engineer, right? Well, yes, it's challenge, right? Because you can see on this slide that the SRE skills are from multiple domains, right? You need to understand a little bit of IT architecting. You need to understand software engineering. You need to understand data science. You need to understand systems management, right? So you see how important the SRE role is critical on this picture, because it is the role that connects all the other personas, and through the system development or solution development life cycle. So it goes from design to develop to build to test, deploy, run, manage, right? And not just for functional requirements, it also goes for non-functional requirements. So that's the reason SRE is very hot right now, because it goes in the middle. It connects all those personas together, but it's challenging because of course, you need to have all those core skills, right? So basically, you need to have systems thinking, like I said, to go to assess the design, the application design, the solution design. You need to have software engineering. You need to understand the software development lifecycle tools and technologies, CI/CD, DevOps. You need to understand deploy and release service. You need to understand automation, for sure. Monitoring and event management, troubleshooting, mathematical models and statistical methods, because you need to analyze big chunks of data. Your decisions are data-driven decision make, and of course, soft skills like any profession in the world, right? Communication, collaboration, organizational knowledge. And not sure if we have time. We can do a little game if you want, or we can go to questions and answers. What do you prefer? What do you think, Bilal? We can either do a game, a fun game here, or we can go to questions and answers.
I think we can go to a game for sure. Yes.
Okay. So grab a piece of paper. I'll do a very quick explanation here. You're going to do this game in your location. You don't need to access anything. So piece of paper, or open a notepad if you're using your computer. You have access to them. What we have here are 12 scenarios, and those are things that happen to our day-to-day activities or our day-to-day lives. For each scenario, you need to put I hate, or I dislike, I like, or I love, right? Love, like, dislike, or rate, or hate, or hate. So read the scenario and think about if you like it, if you love it, if you dislike, or if you hate. How you feel about that? Okay. So this is an affinity game. It's to check, your affinity with, the SRE profession. And of course, you need to be blunt. You need to be honest with yourself. This is, I'll not look at your results, but just to give an example in blue here, put the number, right? Scenario 1, I hate. Scenario 2, I like. Okay. So think about those scenarios. I'll give you some time, 2 minutes. And I think we can put this on the chat as well, right? Let me do that.
Yes, feel free to put in the chat. That's a good idea.
I'll put in the chat. So let's make a little fun. So don't worry. I'll put in the chat. And the other scenarios are here. Okay, so you have the 12 scenarios. The first one doesn't have the number 1, but don't worry, it's number 1. Your boss asks you to resolve a problem that no one else ever resolved. And if you don't know, if you don't understand this, but dislike. No worries. It's just a fun game. It's not a behavioral methodology that we are going to use to increase your salary. Unfortunately, it is not. So again, try to be honest, right? Okay. Let's give 1 more minute. Just reading, but again, I forget, but these 4 possible options: love, like, dislike, or hate. Okay. I'll give you 1 more minute. And then explain how to calculate your affinity, your site reliability affinity. I hope everybody's still okay. So if you didn't feel, don't worry. I'll put this as well. So you need to assign a number of points for each answer. So if you put love, you have 5 points for that question and answer. If you put like, you get 3 points. If you put dislike, 0. And hate is -3, negative. Okay. It means you really don't like it. So let me put this on chat. And based on the points you made, it is your affinity. Hopefully, we don't have any negative number. If I have any negative value, then I didn't do a good job. Okay, so you have that. If you go over 34 points by summing all the answers, yes, you should become SRE today, right? From 20 to 21 to 24, it's high. Maybe you should consider this profession. From 13 to 20 is medium. Well, it's a good option, but if it is below 13, yeah, you don't need to consider this option. Yes, no worries. We have plenty of professions, and we have the project management profession, so no worries. It's not, if it is not for you, okay, right? We have plenty of professions. So hopefully you get some sense about that. And where you can find further information, I put here the SRE books from Google. So if you want to understand the source of this movement, this approach, this new way of working, you have the SRE books. They are free. Of course, you need to read online. Also, I put here a collection of links. So Pavlos, I know Pavlos, and he created this repository on the public GitHub to collect and publish all the amazing, awesome links about site reliability engineering. And of course, we have at Kendrick, we have SRE Practice Lab. So if you want to get practical knowledge on the cloud technology, we have some labs there that you can try. And I don't want to make marketing, but if you think this is the right profession for you, my book is coming soon next month. It's already announced in the Amazon platform, so it's called Becoming a Rockstar SRE, and it is on pre-sales. Right, there is a link here for the Amazon the books platform. So with that, I want to thank you, everybody. You have my contacts here if you want to connect with me on LinkedIn. And I think we have 2 minutes for questions.
Yes, Rod, thank you so much again for this amazing presentation. Before everyone is leaving the session, there will be a survey, a satisfaction survey, which is now popping up. And I'm asking everybody to please fill the presentation and fill the survey. Thank you so much. And also we have 1 more minute for the questions.
Any questions? I think I did a good job explaining site reliability engineering, no questions. Or people here are shy.
No, you did a great job, I think. Thank you again. And of course, for everybody, if you have any questions later, when you are just reviewed again the material of today, then please feel free to either contact me and I will just send those questions to Rod. Thank you so much.
Thank you, folks. Have a nice day ahead of you.
Have a nice day.
Okay.
Goodbye.
Thanks. Goodbye. Thank you.